In this video, we are going to evaluate an integral where the integrand is either a trigonometric function or a product of trigonometric function. We have the following problem. Evaluate integral from 0 to power over 4 of sine cube xd of x dx. Here is the rule for evaluating this kind of integral. So if we are integrating sine to the mx dx times cosine to the nx dx, then we check whether m is odd, in which case we know what to do, or if not, we check if n is odd, in which case we know what to do, or if both are even, in which case we also know what to do. Now let's see. In this case, we have sine cube x. Okay, so that means m is 3. We don't see cosine there. It means that cosine to the n x is 1, meaning that n is 0. So we are going to use the first case here when m is odd. If m is odd, we are advised to write sine. Okay, in this case we have sine cube. Okay, let me change color. Sine cube x is sine x times sine square x, because if you have a cube, it means that a squared times or a times a squared. So now it is said to express sine to the n minus 1 of x by in terms of cosine of x. So that we keep sine x, and what is sine square is 1 minus cosine square x. So this becomes sine x, right, minus times 1, which is sine x, minus sine x cosine square x. Okay, we are, so the next, that means the integral from 0 to pi over 4 sine cube x dx. Remember, we can first evaluate the indefinite integrals of sine cube x dx, then evaluate it as 0 at pi over 4 and take the difference. So, and what is that? Integral of sine cube x is the same as integral of sine x minus sine x cosine square x, or this dx. Now remember, in the end we evaluate at pi over 4, result minus at 0. Okay, so we need to evaluate sine x dx. So what function is such that the derivative is sine x? It has to be negative cosine x, right? So remember, this is the same as integral of sine x dx, evaluated as 0 pi over 4 minus integral of sine x cosine square x dx pi over 4, 0 there. So all we are doing here is, what did I do? So what we want is this. Okay. So integral of sine cube. Sorry. Again, I made a small mistake here. Sine x dx, we say is negative cosine x. Now, if you're evaluating from 0 to pi over 4, then 0 pi over 4, it means that we get negative cosine of pi over 4 minus, okay, I could put the minus in parentheses outside. So cosine of 0. And what is cosine of pi over 4? Cosine of pi over 4 is root 2 over 2. Cosine of 0 is 1. Okay, so that part is done. The next one is integral of sine x cosine square x dx. So to do this, again from 0 to pi over 4. To do this, we say you change our variable u equal cosine x. Then if we do so, we say du is negative sine x dx. In other words, sine x dx is negative du, or negative 1 times du. It means that this integral sine x cosine square x dx is integral of cosine square x. Now I'm switching the position of sine x and cosine square x, sine x dx. Okay, what here? That means u square for cosine square x and negative du for sine x cosine x. And in this case, minus can go out. You get integral of u square du, and which is negative u cubed over 3 if 1 plus constant. But since we are dealing with integration, definite integral, we don't need a constant term. What is u again? U is cosine x. So u cubed is cosine cube x. Then if you want plus constant, I don't need that here. So this just means that the integral of sine x cosine square x dx 0 to pi over 4, that is negative 1 over 3 parentheses. Now you replace cosine of pi, replace x with power over 4, and then take cube minus cosine of, you replace x with 0, then take cube and simplify. So negative 1 over 3, okay, root 2 over 2 cube minus 1 cube. So in the end, integral from 0 to pi over 4 sine cube x dx is equal to, right? We said integral of sine x from 0 to pi over 4 dx, right? Plus minus integral of sine x cosine cube x, sorry, cosine square x from 0 to power 4 also, as we found up there. And this, we found it to be, okay, negative root 2 over 2 minus 1, negative root 2 over 2 minus 1, minus, now, negative 1 over 3, okay, root 2 over 2 cube, minus 1 cube. Okay, so if you take away the parentheses or the brackets on the second one, parentheses here, you get negative root 2 over 2 plus 1 for this one, plus 1 over 3, parentheses, root 2 cube is 2 root 2. Then, and 2 cube is 8 minus 1. Okay, so if you simplify, then you get negative root 2 over 2 plus 1, and 1 plus 1 over 3 times root 2 over 4, that means root 2 over 12 minus 1 over 3. Now reducing to same denominator except the one with square root 2, you multiply by 6 the top, and 6 there will be negative 5 root 2 over 12. Oh, did I say multiply by 6? Yes, okay. Then the other one multiplied by 3, 3 over 3 minus 1 over 3 is 2 over 3, so plus 2 over 3. And that's the end of this problem.